2. Magic. I don't know exactly what's going on. Alright, kiddos, I apologize for the delay. Let's go ahead and keep checking. Number 8, intermediate value pair. Number 10 should be F. Number 12 should be E. Number 14 should be B. 10 F, 12 E, 14 B. Number 26, you can see the different characteristics they identified. The degree is 5. It's a 5th degree polynomial. Leading coefficient is 4. Since the degree is odd, the leading coefficient is positive. They went ahead and just used the silly balls and rising thing, which is fine, which isn't bad. But you guys could have also used our cool notation. So odd and leading coefficient is positive, negative would be that way, positive is this way. So we have rising to the right and falling to the left. So we could say as x approaches negative infinity, f of x approaches negative infinity. As x approaches positive infinity, f of x approaches positive infinity. If you use your snazzy terminology. Huh? Oh, I didn't even look at the name. Wait, on this one. Oh, we can take the I. I was going to say negative, yeah, everything's wrong. It's totally set backwards. Nope. Yep. That's a delay. That's a struggle. Number 28. Did the divided by 4 make any difference as far as the characteristics of the graph? No. Why? It did not diminish the degree at all. What would need to be down there to diminish the degree or to change that? Yeah, some sort of x. If it was x or x squared or x cubed, if there was any x term, I'd be in trouble. But do you guys know how to rewrite this so that it doesn't even look weird? What fraction could you make though?
3/4 x.
Yeah, but it's 3/4 enough though.
Minus a half.
Good. We would need to divide everybody by 4. Well, that didn't work. Anyway, we have to divide this one by 4 and that one and that one. Another way of looking at it is you could think about it as dividing by 4 over 1 is multiplying by 1/4. Yeah, I don't know why it's done. Microsoft Word, I don't know, somehow when they updated it, they made it so that the ink is just a horrible. But, long story short, you can think of the divide by 4 as multiplying by a 4, so then think about it as you bring it in. That doesn't change the degree, that doesn't change the sign, that doesn't change the behavior of the graph. Just a few of you would think it is supposed to, but it doesn't. So, it's a degree of 4, it is a 4th degree polynomial still. Positive, we know it's even, positive, so going up. So rising both directions. Number 36. Oh, computer. You can factor difference of squares. You have these zeros to be plus or minus 9. Each one has a multiplicity of 1. I know it's awkward, but it does. It has a multiplicity of 1 to the 1st degree. So it needs to cross through at 9 and negative 9. And then how could you have found your vertex? That's no fun. Come on. How could you find your vertex? Yeah, it does end up being the y-intercept, right? Plugging in x is 0. But how could you logically think about the intercept? Because couldn't the intercept have not been the vertex? could have done negative b over 2a. And what is b? Exactly.
0.
Because it's not there. There's no x term, right? So we could say negative b over 2a is 0, so x equals 0. Okay, plug in x equals 0, get out 81. So the intercept is going to be at 0, 81. The other way of thinking about it is, aren't most parabolas, it's just a parabola, aren't they symmetric?
Yes.
So then if you have two zeros, the vertex should be halfway in between. So where's halfway between positive, negative 9? 0. So there's a few different ways that maybe you would have figured out where the vertex is. So yeah, they had you put it in your calculator. That was lame. You didn't need to do that. Or just say it's a parabola reflected down and shifted up 81. Alright, let me give you a second. I think you were supposed to fill in the table for this one. Factoring shouldn't have been hard. It hasn't gotten hard yet. Yet be the key operative word. Pull out a common factor, difference of squares. It's even and positive, so it's rising to the right and to the left. After that, it's going to positive infinity both directions. The zeros are going to come out of here and here and here. Question. What's the multiplicity? They didn't ask it, but I'm asking. What's the multiplicity of negative 3? Because x plus 3 is to the first power. What's the multiplicity of 0? What's the multiplicity of 3?
1.
So the graph is supposed to cross through, bounce, and cross through. While going up and going up. So it's going to come from above, it's going to cross through. It's going to come up and bounce. It's going to cross through. I never know if you're sarcastic or not. You still don't know. Okay. Why'd they make a table? To get a few points in between. Remember, if you had plugged in negative 2, could you have thought it just went to there? Yeah, but you're doing the best you can. So you gotta plug in something. They plugged in negative 2, negative 1, 0, 1, 2. And ironically, they showed you a graph as though they had done it perfectly. Although negative 2, well, maybe that is the low point. But if you had done negative 1 instead, because it's easier, you wouldn't have had the same picture, right? Wouldn't you have had, if you had done this negative 1, you could have been like, well, I don't know, it must have do something like that. Remember, I just want to see that you know the ends, that you have the intercepts, that you have the correct behavior of bouncing and crossing through, and that you've at least done 1 point in between each interval to at least have an idea. But I'm not going to mark you down if you went to 1 you didn't realize, because I'm not going to tell you which one to choose. Choose one, plug it in the table. You go from there. If you want to be super snazzy and plug in all of them, sure. But I'm only making you plug in 1 in between to get an idea. This one, intermediate value theorem, they had you looking at the graph. They got very good approximations, little stinkers. They knew what the answer was. But they were able to see a sign change between 0 and 1, 6 and 7, 11 and 12, and hopefully you guys see that as well. There was 1 there. There was 1 in between 6 and 7. And then there was 1 in between 10 and 11. Whoa, wait a minute. Hold on. Guys, help. There's a typo. This says 11 and 12, but the table clearly shows 10 and 11. Do you have which one's right? One of them has to be wrong. What do you guys have? 10 and 11 or 11 and 12? 11 and 12? Okay, so this table must be off, and I apologize for that. You know what? I bet what it is that needs to be a negative. I bet that's right. So then it would be between 11 and 12. Sorry for that. I'll trust you guys. So we'll say the 11 and 12 is right, and we'll say that's a typo. There should have been a sign change. That should have been a negative. All right, cool kids. Any quick questions on evens or odds? 97. Any other questions? All right. As I go ahead and get 97 ready, I'm going to pull up the notes really fast. Sorry, not the notes, the book. I'm going to have you guys go to the next page and get it ready for me to go. So keep your homework spirals out. If you want to look at 97, we're going to peek at it in just a second. Go ahead and get notes ready to go for me on what comes after that example that we ended with yesterday. Wow, only one person asked on 97. Huh. That's a very common question year after year. Let's be real for a second. How many of you guys got stuck on 97, the box one, before you went to Calc Chat? Or just before at all? You got stuck. Okay. How many of you guys skipped 97 and just didn't do it because you didn't like how it looked? Okay. Thanks for being real. That's why it should have been asked as a question. Which Haro did. He helped you guys out, but... You guys notice what you're writing down is another application? So far, I've talked about how long division and polynomial division can help with factoring. Can help with dividing, obviously. That's what I tend to do. But now they can actually help with plugging in. Alright, before we go look at number 97, let's go ahead and talk about this example just because you guys are writing it down. It's still kind of fresh in your minds. According to the application, the remainder after dividing is the same thing as the function value. True? According to this, the remainder is the same thing as the function value. Now, I gave you a super easy example down below. But if this is true, if the remainder that you get after dividing is the same thing as the function value, then the only time you're going to have a solution or an intercept or a zero of a function is when the remainder is zero, right? So, if the remainder equals zero, then the function value is going to equal zero as well. So here's another application. That if when you plug in to a function, the value is zero, that means the remainder will be zero, which means x minus a works. X minus a is a factor. Which can be helpful because instead of doing tons and tons of different divisions and you keep on getting remainders that aren't zero, and you're like, oh, this one didn't work, oh, that one didn't work, oh, that one didn't work. If you can plug in at the very beginning, maybe you can simplify the process, and just by plugging in, answer the question whether or not you should even try this in your division for factoring. So for example, if you plug in 1 to this function, what do you guys get? Plug in 1.
-5, -2.
You're going to scare me a little bit. Alright, take your time. Plugging in 1, what do you get? 2 minus 7 plus 3. -5 plus 3 is -2. True. Couldn't you have also switched these two because it's addition and then 2 plus 3 is 5 minus 7 is -2? Yes. But either way, this wasn't meant to be a hard mental math one. So, 2 minus 7, -5 plus 3 is -2. Or 2 plus 3 is 5 minus 7 is -2. Either way, long story short, is the function value 0? And the answer would be no. Which means the remainder is -2. Which means where I want to do synthetic division with 1? No. Where I want to do polynomial division, well, wait a minute, hold on. If I'm putting 1 in the box, what factor is this representative of? X minus 1 is not a factor. Because you put the 0 in the box for the synthetic division. The 0, which should be a 0, but it's not, or it would be a 0 if it went in evenly. I can say by plugging in 1, x minus 1 doesn't work as a factor, so forget it. What if you plug in negative 1? Long story short, is it 0? No. So negative 1, x plus 1 isn't a factor. Can anybody find a factor just by looking at that function and thinking about plugging in different values? Anybody find a 0? Because that's not one we can pull out a common x and then do it the difference of squares. That's one where plugging in 2's right now. Plugging in 0 doesn't work.
27.
0 doesn't work. Plus or minus 1 doesn't work.
21. No.
2 didn't work either?
3 didn't work.
Uh-oh.
Do we go negative?
Worry. Struggle. Now, if the cubic function, is it going to have at least 1 0? Has to have at least 1 that crosses through or crosses through. It could have only 1.
18, 16.
So plus or minus 2 doesn't work?
Yeah.
You guys already tried plus or minus 3?
Yeah.
And as you get bigger, the problem is, are these two going to cancel each other out if you're getting bigger and bigger numbers?
No.
Okay, so pause. Has anybody figured out in between what 2 numbers the 0 must happen? If you plugged in a lot.
1 and 0.
1 and 0? How come? So when you plug in 1, you get a negative, and when you plug in 0, you get a positive. Oh, hey. Intermediate value theorem. So we could have figured out that there is going to be a 0 in between 0 and 1. Did anybody find another place? What's negative 1? Is that a negative or a positive? That's positive, so that doesn't work. Did I plug in 2? That's a positive, right? Oh, so then in between 1 and 2 is going to be another one. And hey, if there are 2 zeros, there must be... Well, I guess there could just be 2 zeros. Long story short, what am I trying to tell you? You were looking for nice zeros by plugging in 0, plus or minus 1, plus or minus 2, plus or minus 3. It wasn't working. So what did I say? Hey, look at the sign changes. Isn't there a nasty decimal one? Isn't there a nasty decimal one? So maybe there were no nice ones to be found. So there are a couple different ways of trying to think about zeros and trying to think about factors. One way is to try to do division right away, but if we can plug in some values like 0, plus or minus 1, plus or minus 2, maybe we can narrow them down and not even do the division if we know it's not going to work, because when you plug in, it's not 0. But then we can also think intermediate value theorem, and if we see a sign change as we're plugging in numbers, we can say, oh, there's a nasty decimal one. I bet this is one I'm not supposed to do by hand. Okay, let's keep going. We're going to keep going in our notes, but let's go into pause really quickly. I do have... Oh, didn't we just solve that? Okay, never mind. That whole page is for not. All right, number 97. Let's go peek at it. What was weird about it? You plan to construct an open box from a square piece of metal. Do you guys remember in elementary school you would like cut out the corners and like fold out their tape and make like little boxes that wouldn't hold anything, but that's okay. So then number 97. You plan to construct. Oh, we already got 10 pens. Oh, 15. Silly goof. It's okay. You're cutting out equal squares with sides of length x. Oh, they even showed it to you guys. Look at you, spoiled rotten. Okay, so we know that 36 is all the way across. You're cutting out x, so you're subtracting an x, and you're cutting out x, you're subtracting 2x. Does that make sense why the distance in between is 36 minus 2x? Whole minus x minus x. Okay. Write v. What's volume of a rectangular solid? Did they look at that? Base times width, length times width times height. Sounds good. So length times width times height is what v normally equals. This is a square piece, right? question, what's my length after I cut out the x's and after I fold up? Yeah. 36 minus 2x. What's my width? What's the other one going to be? It's a square. Good. 36 minus 2x. What's my height when I fold that piece? Good. It's going to, oh, we just showed it to you. Look at that. Go team. I know, right? Now the domain got a little bit harder because you have to think logistically. If I literally had this piece of material, how small could x be? Could be a half. Could be a 4. Could be an 8. Yeah, if x was 0, are you folding anything? No. So we're going to say that x has to be greater than 0. How big can x be? I think you're cutting it out and you only have 36 inches. 36. Yeah. How big can x be if you have to cut it out from both sides?
Can't be bigger than.
It can't be 18 because if it's 18, what just happened to your whole side? Your whole little lip? Cut off 18, you just cut off the whole side. You can't fold anything. It's all wrong. So it has to be bounded by 0 and 18. How'd you get 18? Cut 36 in half because you're coming in. Now, what if it was 17? How big is that little piece you're folding? Right? In your weird little tiny box. But either way, it can't be 18, it can't be bigger than 18, or else you don't have anything you're cutting. What's C asking for? Make a table. How? Oh, I bet this guy needs to go into my Y1, my calculator. Go to your table. Use the table to estimate the dimensions that will produce the maximum volume. If you make a table, x is x, but what is your y representing? Volume. So you're just going to look in your table and say, hey, where does it look to be the biggest between 0 and 18? Did anybody do an estimate? What did they find? Oh, we got confused. Okay. So that means I should have seen a lot more hands get raised and some of you weren't being real. You didn't tell me you got stuck. At any point, you didn't tell me that you skipped it, so I don't know what the really other option is besides cheating. If only it was them. Alright, put in the Y1, go check out the table. You guys look at your table between 0 and 18. What's the biggest-ish number you can see? 1,300 is your volume. What'd you get, like, what was the x for that one? Oh, 13. Do you guys agree with 13-ish? Seems to be the biggest? And you're probably just going by ones, because if you go by decimals, it would take forever. So it says, use a table to estimate the dimensions that will produce the maximum volume, x equals 13. But what happens when you actually go to your graph? Now you're using your graphing calculator, second trace, right? And hitting the maximum feature. What do you actually find here? Oh, you didn't do the math. Has anybody done the math? He's working on it. Let's see how close to 13 it is. My guess is it's between 12 and 14. Oh, it said to estimate. Huh. Yeah, I would have just used the max feature, not estimated. So much more precise. Okay, you should probably play with your window. And you said it was like 1,000 something? Yeah, 1,000 something. So you probably have to make your Y max to be like 1,500 if you're still playing with your window. Your x min could be 0, right? Your x max could be 18. And then your volume, which is your y, make it 1,500 based on what you saw on the table. Maybe that's one of the reasons there you go to the table. Did you find that? Did I find a max? Station, is it looking something?
For the table, I'm actually going to use it as yeah, that's awesome.
Oh,
What is that? Like 5? Is that like, yeah, 5. And then when I did the math,
both of you guys were?
5, and then you adjust the limit to 0.
Okay. Yeah, so maybe yours was a little bit off. Because it seems like they're getting 5.99. and then their table they saw it around 5, and the volume was around 3,000. Maybe you missed one of your factors. Do you find it? Oh, it's already gone. For the rest of you guys, good calculators, it seemed like 5.99-ish?
Yeah.
So, all they were having you do was, you had to think about the picture, think about some visual, spatial stuff going on. Make an equation from length, width, height, which you might have had to review from geometry or from the cover of your book. The 0 to 18 was hard, but it did help once you got that to make your X window to know where to look. When you went to your table, you were able, and this might be helpful in general, if you're trying to find the max of something, couldn't you go to the table and just look and say like, oh, hey, this is going up in the hundreds or up in the thousands, and that could help you with your window? We didn't think about that with the graphing calculator handbook. Maybe I should have. I haven't seen that application or figured that out before. You can go to your table and figure out how high, and then you were able to know, make your Y max to be like in the 3,000s somewhere, and then solve. I think that's the end, right? Yeah. All right, Kyle, did that help then?
Yep.
Okay. Everybody else, what should you say to Kyle?
Thank you.
Yeah, the rest of you need to be real, huh? All right, here we go. Back to notes. Question. This question goes a little bit in the opposite direction, because this one says, use synthetic division to show that x equals a is a solution. Now, I'll show you what that really is talking about in just a second, but first of all, we know it says use synthetic division, so we're like, whatever, we get practice, right? How do we do synthetic division? Did you guys get it from the example that you copied down? Okay, the 2 goes in the box. Because it's x equals, it's not x minus, so we use the 2. It's like the 0. Coefficients will be? There you go. Careful. Gotta make sure you have one for every degree term. That's one of the common mistakes. So 1, 0, because there's no x squared. -7 for the x term, then plus 6. Why am I drawing a little line right here? I need to talk about it. That's the remainder, because when I divide an x cubed by an x, the degree diminishes by 1. So instead of having an x cubed squared x in constant term, it's only going to have 3, and the last one is the remainder. Walk me through the process. How do we do synthetic division? Down the 1 and then multiply and add, and then multiply and add, and then multiply and add. What did we just show? Actually, we showed a lot of things. But what they were specifically asking for was do synthetic division to say, oh, hey, yeah, f of 2 is 0. Now, some of you are like, that's dumb. What could you have done instead to show that f of 2 is 0? Plug it in, right? 2 cubed is 8, minus 14 plus 6. 8 and 6 is 14. 14 minus 14 is 0. That would have been an easy plug and chug. But what if you had a fraction? Maybe you wouldn't have liked to plug in and check 1/8. Then maybe it would have been a 0. Now it's not. But maybe 1/8 would have been a 0. Maybe it would have been easier to do synthetic division with 1/8 and get the 0 rather than plugging in and cubing a fraction, which some of you get freaked out by. Bless you, bless you. However, even though this technically is the end of this problem, can you guys help me out and say what else we figured out from the synthetic division? We did figure out that f of 2 is 0 from the remainder being 0. That's true. But what else did we figure out? Yeah. I can say that f of x, or x cubed minus 7x plus 6, is equal to, what can I say? X minus 2 is one factor from this, and what else? X squared plus 2x minus 3. The other thing I could have figured out, if you guys remember that, those two applications we worked on yesterday, is that x cubed minus 7x plus 6 all over x minus 2 is x squared plus 2. Anyway, so not only did we pull out this, but we also could have pulled out that one. Quite the sigh. Oh, hey, that's not too bad. So, what are you doing tonight? Practicing. Practicing what? Division. What kind? Synthetic or? Follow the directions. We're just making you practice the different types and different applications. However, let me go ahead and Do you guys want to see the homework assignment so you can write your spiral in case you haven't started it yet? Oh, you already started it? Go team. But just in case you haven't started it, I'll put it up there anyway as I pass out your tests. I guess you guys can check 14 if you already did it last night. Anyway. And maybe if someone started homework last night, we can find us a really hard one that we can do together if there's time. That'd be fun. I think there are a couple messy ones. Alright guys, this is in no particular order whatsoever. I'm going to go ahead and get these tests out to you. Once again, these are the Chapter 1 tests. Each multiple choice was worth 4 points, I think. Each wrong answer was worth 8. And some of you are very, very, very fortunate. Because when I took off, remember your lowest wrong answer? Some of you, that literally made a letter grade difference. Now, that sounds great now, but the dilemma is I need you guys to look on the back, and if you see, don't worry, I have no idea who this is. If you see a little squiggle through one, that means I did not count it, I did not take off for it. But I need you to figure out how many points that would have been. I showed it, I graded it. How many points that would have been. Subtract it from your score and say, is that the score I want next time? And if the answer is no, you need to realize this was a one-time only grace thing because of the chapel day and because of, you just can't tell me what. Stop spying. Anyway, if you got a through 1, that means I did not take those points away. And if you didn't get a, that means you didn't miss 4 or more on any of your wrong answers. So I just gave you a +4 because it was more beneficial to do that. I didn't do a +8 because I gave partial credit lots of different places, and I was not about to randomly give a +8 and have someone get 108. That was not quite acceptable. So I did have quite a few 102s. All right. So I called your name. Come on down and get it, and
we got that little spoiler line through stuff.
Yes. Still have to correct it because that means you missed it. I was just really gracious in not letting it count towards a grade this time. Mostly because of time and the weirdness of not having a copy and being in trouble. Caroline, come down. Kevin, John, Ryan, other Ryan. He's not here.
What is?
Janelle. Victor, Jacob, Johnny, Toby, Andrew, Dean, Joseph, Thomas, Kobe, David, Rebecca, Patricia, Jack, and Abby. Got 100.
Did you say so close and you got one out?
Oh, that's switch.
What is wrong with you? No, I'm not finished. That we got one.
Pause. Look at your back page. Did you get a squiggle? And if so, figure out how many points I did not take off, and then think about your score minus that many points. And be like, ooh. A, be thankful for grace. B, be thankful that circumstances were not ideal as far as the chapel day schedule and you guys going along on it. But C, think about how you can study better next time. Yes, you need to do corrections on anything and everything you missed points on, including the squiggled one. Multiple choices were 4 points each, so if you missed all 4, that means I didn't see work that was close or getting you to the right answer at all. If you missed -2, I gave you partial credit, which means something was right. If you need more than one correction paper, you can print it offline or you can grab one on the way out. I need to get some more printed. Any other questions that you guys can see in general about the test or correction? Today is Tuesday. Let's go ahead and have it due.
Wednesday.
I would say Friday, but that's me. I'll give you a weekend. I would say Monday, but then you'll all forget. I'll say Tuesday, but you should have it done Monday, so it's not like taking up time, etc., etc. I'm gonna check out your calendar real fast too. We're going to have a test coming sometime soon. We have section 2.7.
Right now,